Hey guys, welcome to your Unit 9, Lesson 5 notes on choosing the correct color to write in. I'm just kidding. On solving quadratic equations by completing the square. Also, I just spit a little bit, so I hope you were able to hear that. That was quite amazing. By the end of the day, you'll be able to solve quadratic equations by completing the square. Let's do some basic examples right now. Okay, here you go. I'm trying to find the square root of 9. Which means something times something equals 9. So if I made a square and it was length this times length, and you know the area inside is 9, it has to be 3, because 3 times 3 is 9. Okay, similarly, now a new square. The square root, or rather, inside my square is 25. Square root of 25 is 5, because 5 times 5 is 25. Man, that took a long time to write. I'm just gonna, can I just write like 5 times 5? Or even, that was so fast. 5 squared is 25. But guess what? I'm gonna throw a challenge question on there. Hello, what about negative 5? Do you know that negative 5 squared is also 25? 5 squared is the same thing as negative 5 squared is 25. Equals is. That was lame. Okay, new question. New puzzle for you. Now it's 100. This is a square of 100. Square root of 100. Oh, I'm sorry. I didn't even finish the last one. Yes, it's positive 5, but it's also negative 5. So you can write plus or minus 5 like that. That means we also need to do plus or minus 3. So square root of 100 is not just 10. It is plus or minus 10, because 10 squared is negative 10 squared is 100. Also, square root of 49, plus or minus 7, because negative 7 squared is the same thing as 7 squared is 49. So make sure you remember your negatives. Negatives matter too. Okay, cool. Now what's the square root of this guy? Oh man, I'm just gonna draw a bigger square. Okay, we've got a square. It's x squared plus 49, and then this adds up to 14x. Well, that's gotta be x plus 7x plus 7. So that's x plus 7. Nice, because it's x plus 7 squared. Notice, we're just looking for the square root of this last number. That's so nice. Okay, do it again. Similarly, instead of 49, we've got x squared plus 25. And this time the middle stuff adds up to negative 10x. Well, I know 5 times 5 is 25, but 5x plus 5x is positive 10x. So this needs to be negatives. So that's a negative 5, negative 5. So that gives us x minus 5. Hey, notice that fun pattern. 7 is the square root of 49. Negative 5 is a square root of 25. Use that to predict what is going to go here if we've got x squared plus 6x plus 9, and that needs to add up to 6x. Oh, square root. The square root is going to be 3. 3x plus 3x gives us a 6x, so we've got x plus 3. So yeah, we've got the square roots here. That's cool. But you know what other pattern we have here? You multiply them by 2. 7 times 2 is 14. So yeah, we've got a square root, but we've also got our times 2. Negative 5 times 2 is negative 10. 3 times 2 is 6. So yes, you're looking for the square root of the C number if we have x squared plus bx plus c. We're looking for the square root of the C number, and we're looking for b, but half of that. Like what times 2 is b? Well, that'll be b over 2. So that's going to be the same number. Wow, that's our key idea of the day. Okay, So if you have x squared plus bx and you need to add something, you need to figure out, okay, what is your plus c going to be? Well, you need to start out with your b first. You need to find out what is half of b, and then you need to square it. Whatever that is, add it to your polynomial. Here it is. Here's your key idea of the day. Know it, love it, memorize it. So our c instead is going to be 1/2 of b squared. In fact, we can just do b over 2. Oops. We just do b over 2 squared. Because that's b times 1/2 squared. I'm just going to take that idea right there. I'm going to bring it down. All right. Okay. We need to add b over 2 squared. Well, what's our b value? Here our b value is 14. So that'll be 14 over 2 squared. Half of 14 is 7. And now we need to square it, 49. So to make this a perfect square, we just need to add 49. I'm just gonna highlight it in blue. There you go. And I think, did we see this one earlier? 14x and 49. We totally did. Look, it's the same guy right there. Square root x plus 7. That's the same thing as x plus 7 squared. Notice this 7 here is this 7 here. That's no coincidence. Those will always be the same. So keep that number in mind. Remember that. It's like Mufasa talking to Simba. Remember. Let's do it again. So we're looking for b squared over 2. And then we're going to square it. Here our b value is -8. So we need to figure what is half of that? What is -8 divided by 2? And then we'll square it. Well, -8 divided by 2 is -4. Oh, we need to square that. This guy that we square, that's going to be the square root. -4 squared is 16. So we will add 16. Cool. And that'll end up being x minus 4 squared. So the factored version of this is x minus 4 squared. But we're looking for, we need to add 16. We needed to add 49. Here, we are again looking for our b term. Let's have it. Have as in divide by 2. And then square it. Oh, did I highlight where that came from? Bink. Wrong tool. Bink. Okay, there we go. Now this is what we will square to get our answer. That's 100. So we need to add 100 to make this a perfect square. And that perfect square will end up being x minus 10 squared. This gray part is optional, but fun to have. And then finally, what do you think this is going to be? Cool. You need to add 64. Because that'll give you x plus 8. Get x squared plus 16x plus 64 from FOIL. Sweetums. Okay, now we need to solve each equation by taking the square root of each side. But guess what, guys? 13 isn't a perfect square. Also, negative 13 doesn't even have a real square, because that's negative. Gross. But we're going to pretend that it does. That's kind of how some of the most fancy math works, is you just pretend and you see what happens. So let's take our negative 13 and move him to the other side. by adding 13 to both sides. That'll leave us with x squared plus 12x, leave space, equals 13. Okay, cool. Now we need to figure out what goes in this space. Well, to complete the square, to make this a perfect square, we need to take our b term and divide them by 2. We get 12 over 2, and then square them. That'll be 6 squared, which is 36. So we need to add 36 to both sides. So we're going to add 36, but there's an equal sign, so we need to add 36. Oh, cool. But we did this because now this guy right here is a perfect square. It's a perfect square that's x plus 6 squared. Isn't that so nice? I'm going to get this out of the way so you can see that real quick. If we FOIL x plus 6 times x plus 6, we get x squared plus 6x plus 6x plus 36, which comes out to this guy. Or if we factor this, we get this. So, same thing. Alrighty. Also, 13 plus 36 is 49. Sweet. Now, we're just solving this equation. Oh, sweet. I know how to get rid of that squared. I can just take the square root of both sides. And that's going to cancel out with that square. So I get x plus 6 equals, what's the square root of 49? It's 7, right? No, it's plus or minus 7. So now we split this guy into two different equations. We say, okay, well, what happens when it's positive 7 and what happens when it's negative 7? What happens when x plus 6 equals a positive 7? What happens when x plus 6 equals a negative 7? Minus 6, minus 6. Hey, we're going to minus 6 over here too, so I'll save that for later. We get x equals 1 or x equals negative 13. End of story. Isn't that so great? And then, of course, plug them back into your original equation. See if that does, in fact, make it 0. It will. Yay. Cool, huh? 3 more. We can do this. Okay, so first we need to clear a space. I'm going to keep my color scheme the same, so I'll leave this up here. We need to clear this guy out, so we're going to add 16 to both sides, leaving us with x squared plus 6x something equals 16. Now, what goes in this space to make this a perfect square? Well, we need to take our b term and have it and square it. So that'll be 6 over 2 squared, which is 3 squared, which is 9. So that means we need to add 9, but we are adding 9 to both sides. That's so important. Remember to do that. Simplifying, x squared plus 6x plus 9 equals 25. Oh, but hey, this 3 squared, we did this whole thing. We made this a square because x squared plus 6x is x plus 3 squared. Awesome. Now we can solve this equation by taking the square root. The square is going to cancel out with the square root. That's really nice, leaving us with x plus 3 on this side, and the square root of 25 is 5. Positive or negative. So we split this guy into two equations. Either x plus 3 equals 5 or x plus 3 equals negative 5. And now we have to figure out what is x going to be to make that true. Well, we're going to subtract 3 from everybody, giving us x equals 2 or x equals negative 8. And that's so fun, so fun. We got 2 more. It's the same thing. Okay, we gotta get rid of this 3. Add 3 to both sides. Now we're left with x squared plus 2x plus something equals 3. What is this something gonna be? Well, let's use our b. It's going to be half of what b is, so it's going to be 2 over 2, and then we'll square it. So it'll be 1 squared, which is 1. Yay! So we add 1 to both sides of our equation. Now we get that x squared plus 2x plus 1 equals 4. But the whole reason we completed a square is because this trinomial is equal to something squared. It's equal to x plus 1 squared. Apparently that's 4. So now to get rid of that square, we're going to take the square root of both sides, so that cancels out. So we get x plus 1 equals plus or minus 4. Split them up. X plus 1 equals 4, or x plus 1 equals negative 4. We're going to subtract 1, subtract 1, subtract 1, subtract 1. So x equals 3, or x equals negative 5. What? I might have done something wrong, because that doesn't make sense. Where did it, because I went to check my work, and that doesn't work. So where did I go wrong? Oh, I see what I did. I said the square root of 4 is 4. Square root of 4 is not 4. Square root of 4 is 2. So it's plus or minus 2. X plus 1 is 2. X plus 1 is negative 2. So we get 1 and negative 3. That makes a lot more sense. Alrighty, cool beans. Last one, last one. Hey, look, this already doesn't have anything. It's got x squared plus 2x, and there's a natural space there. What do we need to add here? Well, we just need to take our b over 2 squared. Our b is 2. So we get 2 over 2 squared. Sweetums. 1 squared is 1. So we will add 1 to both sides. Giving us literally this exact equation. But it doesn't need colors. Bye. Okay, the whole reason we made this guy is because he's a perfect square. He's equal to x plus 1 squared. And that's equal to 1. But guess what? To solve this equation, let's just take the square root of both sides. Square and the square root will cancel out. That's why we did it. So x plus 1 equals plus or minus 1. Great. We split them up. So x plus 1 equals 1, or x plus 1 equals negative 1. So we get either x equals 0, or x equals negative 2. We did it. We found all those equations. Tune in for next time when you find out that sometimes completing the square is the hardest way, and spoiler alert, we could have factored this to x times x plus 2, and we could have just used the zero product property all along. What? Crazy. So that's the good news, bears. Doesn't matter which method you use because they always work. Hey, have a great time on your homework.